Okay, we're told in a recent poll of 755 randomly selected adults, 589 said it was morally wrong not to report all income on tax returns. We want to use the 5% significance level to test the claim that 70% of adults say it's morally wrong not to report all income on tax returns. And it asks us to identify a bunch of stuff. Now, the first thing, and I've pulled this out of the notes, is list out all the known information, necessary formulas. So you can see down here, I've pulled the information out of the problem. And define the formula. Remember I have this under assignments and then test resources. I have the formula sheet if you want to use mine. And on the formula sheet on the second page, test statistic proportion. So once we say that, oh, we're doing a proportion, I know this is the one I want. So I've also brought that over. So now I have my basic information. Now I want to find my null and alternative. So I'm going to go back here because they wanted me to put it in here. So remember, the null is always equal to, and we want to test that 70%, so we know that our null has to be equal 0.7. So like I know that that's not even 0.3. So I know I have to be E, F, E, B, or D. Oh, why are these in such weird order? But anyways, B, D, E. And then we want to, what was the asking? Test the claim that 70% of adults say it's morally okay. So we're just testing whether this is or isn't. So then not equal. So then this is, we didn't say less or more, so we just want that it isn't 70%. So that's what we want to prove. So that's what our alternative is. Because remember, our alternative always is what we want to prove. Now we need to find our test statistic. So I'm going to come back over here, and I'm using this formula to find my test statistic. And so first I want my sample P. That's my proportion. So that's what we got on our thing. So my P hat in this case, my P with little hat, P hat, is 755 divided by 589. So 755, oh, I need two fives, divided by 589. Oh, because I've got them upside down. I'm like, how did I have more? 589 out of 755. There we go. That makes a lot more sense, right? 589 out of 755. Okay, so about 0.78, about 78%. So that's what's going to go here. A lot of times what I do when I'm working my problem is I'm going to just actually put in the fraction because I'm going to keep it in my calculator. I'm not going to round. And then I'm subtracting from my proportion. That's what I'm testing, 0.7. Now down here there's no hat. This is 0.7 times 0.3. And then this is over 755, my total N. So now when I come back here to my calculator, so I've got this. I'm going to subtract this from 0.7. And I'm going to divide by, and I've got the square root of, and what do I have up here? 0.7 times 0.3. And then all this is divided by 755. And then in parentheses, I like lots of parentheses. So here we go. That seems really, really high. So I look at that and go, oh, I don't know that that's true. So I'm going to actually try that again. Because I think I have, oh, I know exactly right there, my square root's off. So when I looked at this, I thought that's pretty big. So it didn't seem right, so I'm going to try it again. And I usually run these twice anyways, just because they're so long and involved. So minus 0.7. Okay, so that's my top. Now divided by square root. Okay, so I'm going to do this in two parts. 0.7 times 0.3 divided by 755. Now in parentheses, parentheses. There we go, 4.8. That seems much more reasonable. So here we go. This is my test statistic, so I'm going to put this in here. So let's see how many decimal places. 2, 4.8, 4.80. Okay. So that's my test statistic, but now I need something to compare it to. I need my critical value. So remember, we always draw the picture. So this is two-tail because we have, coming back here, we have not equal, so two-tail. Had we had less than or equal to, we'd only be working in one tail. So I need to know what these two values are. Now my significance level was 0.05. So that means between these two, 0.05, that means in each one of these then is how much? 0.025. Now this is a z-score test because I'm working with the proportions. So I come here and I'm looking in the body of this for 0.25. So I look for that. That's right here. And that's negative 196 and positive 196. And this typical one, that's a really typical one, you're going to find that you memorize these after a while. So negative 1.96, and over here is positive 1.96. So now what we have to ask ourselves is, does our value that we just got, 4.8, does that fall in either red zone? Well, yes, it does. It falls in this red zone out here, right? Because it's larger than 1.96. The red zone is my rejection zone. That means I will reject this because it's greater than. Had it been smaller than this as well, I would also reject it. So I come back here and I am going to reject the null. There is sufficient evidence to warrant the rejection of the claim that 70% of adults say it's morally wrong not to report. So did we do all our steps? Well, yes, we stated those. We got those. We found the test statistic. We found our critical value. We compared them with our picture. We then that gave us our decision, which was reject. And then this final statement here, this is our restatement of what it means. So let's check our answer. And oh, we got it right. Don't we feel good? I always like being told good job. So that's how this works. It seems like a very long process, but it's really not. The crux of it is this picture. That's going to make the decision, do I reject or fail to reject, really easy. If you don't draw the picture, you're going to look at those numbers and go, what do I do? What do I do? Draw the picture. That's how you're going to know what to do.